Okay, today we're going to start out by taking a look at this diagram here. And our circle O, you can see that I have two different angles that are highlighted. Now, the yellow angle would be our central angle because the vertex is at the center. And we had discussed previously that if the central angle, let's say my central angle measured 110 degrees, that the arc from C to R would also measure 110 degrees, so that the intercepted arc is equal to the central angle. Now, let's take a look at the green angle here. The green angle, angle CAR, also intercepts that arc. Well, is my opening for this green angle as large as my yellow angle? No, it's not. It's actually smaller, right? We can see that it doesn't open up quite as much. This green angle, in fact, it would measure 55 degrees. So what is the relationship here? Well, the green angle is half of the intercepted arc. This green angle is called an inscribed angle, where the vertex is actually on the circle. To me, it's fitted perfectly inside my circle. So, green angle, the inscribed angle, it is half of the intercepted arc. And lesson 12.4, that's what we're going to be discussing today. So let's take a look at some definitions. I guess by formal definition, it says that an inscribed angle is an angle that has a vertex on a circle and sides that contain chords of my circle. Intercepted arc is an arc that has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. The inscribed angle theorem says that in an angle, if an angle is inscribed in a circle, then the measure of the angle equals half of its intercepted arc. So again, if we knew that this arc was 60 degrees, we would know that this angle would be 30. Okay, so let's take a look at finding some of our requested measures. Let's take a look at example A. In example A number 1, they're actually asking me for the measure of angle XNM. So my measure of angle XNM is wanting that angle right there. Well, I can see that it intercepts this arc of 80 degrees, and so we know my angle inscribed would have to be half. Number 2 is asking me for the measure of arc XN. Now, it doesn't tell me the measure of arc XN, which way to go around my circle, but actually because we see that this is a diameter, the measure of arc XN is exactly half of my circle, so we know that has to be 180 degrees. Number 3 is asking me for the measure of arc MN. Right in here. Well, again, I'm going to use my semicircle. If I know that XM is 80, MN is going to have to be the leftover, and that's going to have to be 100. Let's take a look at the second figure. Number 4 is asking me for the measure of angle DAE. So my angle DAE, well, that is intercepting my 76 degree arc. Half of 76 is going to be 38, so angle DAE is 38 degrees. The measure of arc ADC. Well, the measure of arc ADC is a major arc, and we want to kind of go in the order of the letters, so ADC will actually be this whole thing. Well, this can be kind of hard to see. I don't know for sure that I have a diameter, so I can't use 180. I only have this 76. But the other kind of sneaky part here is that I do have this inscribed angle of 135 where my endpoints are A, and I'm going to say A and C. If this is 135, it's my inscribed angle meeting that intercepted arc. Well, then we're going to take 135 times 2. This would be half of the intercepted arc, and in the end we would find out that would be an arc of 270 degrees. Okay, let's take a look at a couple more theorems for our circles. The first one talks about angles that intercept the same arc. It says if two inscribed angles of a circle intercept the same arc or congruent arcs, the angles must be congruent. Well, as you take a look at the picture here, I have one inscribed angle, DCA or ACD, and my second one, DBA or ABD. In this case, both of those angles are intercepting the arc from A to D. And so what that is saying is that this angle here must be congruent to this angle. As we had said before, if this was a 50-degree arc, we know that this angle would have to be 25, but this would also have to be 25. They would have to be congruent. The second theorem. Well, the second theorem says that an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. I can see here my inscribed angle FGH with endpoints F and H, that's on the diameter, passing through the center. So this would have to measure 180 degrees. This angle here then would have to be a right angle, or 90 degrees. And finally, the last one. If you look at the diagram, you can see that we have a quadrilateral perfectly fit inside the circle. So the endpoints are on the circle. They're going to call that a cyclic quadrilateral. Okay? If a quadrilateral is inscribed in a circle, then its opposite angles are going to be supplementary. My cyclic quadrilateral here. I don't know that angle L and angle N are congruent, but I do know if those are a cyclic quadrilateral, those are going to be supplementary. Opposite angles likewise going this way. Let's look at applying some of those theorems. In example B, they're asking me to find the measure of angle T. So my measure of angle T right here, well, I can see I don't know this intercepted arc. But I do know that angle U also intercepts that same arc. What that tells me is that angle T must be congruent to angle U. So if I need to solve, I can take my 3x minus 5 and set that equal to the 2x plus 15. If I want to subtract 2x from both sides, add 5 to both sides, we would find out that x is 20. Now it's not asking me for x, it's asking me for angle T, so I need to remember to substitute that back in. And we would find that the measure of angle T comes out as 55 degrees. Number 2 asks me to think about the measure of angle F. This one's a little bit trickier. My measure for angle F. Again, I don't have an intercepted arc measure over here, so I can't determine it from that point. What I do see, though, is FH is a diameter, and my angle G actually intercepts with endpoints at F and H, which means angle G is going to have to be 90 degrees. I have my triangle here. I have angle F at 4x plus 2 and angle H at 9x minus 3. I could set these equal, adding to 180, or if this is a 90-degree angle, then I know that these two must be complementary, and so they must add to 90 degrees. So I can take 4x plus 2 plus 9x minus 3 and set that equal to 90. In this case, we would look at combining our like terms here. So I have 13x, and I'm going to have a minus 1, or 13x equal to 91, which would tell me that x is 7. Now again, it's asking me for angle F, so I'm going to go ahead and plug that in. 28 plus 2, the measure of angle F must be 30 degrees. Number 3 asks me to think about finding the measure of angle X. As I look at my diagram here, I see I have a cyclic quadrilateral, and what that told us was that my opposite angles must be supplementary. Finding my angle X and finding my angle Y, I'm simply going to find the complements. 180 minus 60, so the measure of angle X must be 120 degrees. 180 minus 95, my measure of angle Y must be 85 degrees. Okay, last one, number 4. This diagram actually can prove to be a little bit trickier. We're going to find P, Q, R, and S. Now we don't necessarily have to find that in that specific order. In fact, as I look at my diagram, the very first thing that I see is I see a measure for R. 29 degrees here, then this intercepted arc is going to be double that, 29 and 29, and so angle R must be 58 degrees. As I further investigate, I notice that S and Q are congruent, and they are congruent because they have equal chords. Now, a common mistake is that kids will want to say that angle Q is 87 degrees. Angle Q is not 87 degrees necessarily because this is not in the center of my circle. So I can't use it for that. Now, ironically, it actually does come out. I have some vertical angles, and if I take a look at my triangle and I do some subtracting, I would find out 180 minus 87 minus 29, that this 64-degree angle actually is an inscribed angle to intercept my arc P. 64 and 64 is going to tell me that P is 128. Now, left over, I have S and Q, which are equal. If I took 360 and I subtracted 128 and I subtract 58, I would find that I'm left with 174. Well, 174 degrees split in 2 actually does give me 87 degrees. Now, I happen to think that the measures, or that my diagram, the numbers on my diagram might be slightly off. This does not measure 87 necessarily because it's not a central angle. It just happens to work out that way. Okay, if you have further questions on this, please feel free to stop in and visit with me.